Hi everyone. So today I am here to cover one of the most important areas of the portfolio theories, and most of the students are also requesting please put this on YouTube directly. So that's why the model that we are going to cover today is the Sharpe's single index model. Without taking much of your time, from the exam's point of view, what is really required, and without deviating the conceptual clarity of the Sharpe's single index model, I am going to today cover the entire Sharpe model using one question from my study material. I mean, this question, my study material means I didn't frame this question. This was taken from the institute question only. Latest exam question from the Sharpe's single index model I have taken, which is question number 31 in our study material, in my material, I mean. Okay, institute study material also same question is there with the same numbers essentially. So taking this particular question as a base, I am going to cover the entire Sharpe single index model with not exceeding 1 hour 15 minutes. So spend your 1 hour 15 minutes and get perfection on Sharpe single index model. So till today, if there are any doubts regarding Sharpe model, everything will be covered. I mean everything means really everything. All kinds of doubts will be cleared. With notes, everything I will put. I won't give time for you to write the notes. If you want, you pause the video. Okay, on the screen answer will be available. You can copy. Okay, in 1 hour 15 minutes max, I will brush out the entire concept regarding this Sharpe's single index model. Okay, so what is this Sharpe single index model? Everyone is having a terror about this model just because of one reason. That one reason is using error term EI. How that EI came, everything we are going to analyze in the today's session. So let us take the question first. Once after taking the question, we will be going into the analysis part. Okay, there are two angles of Sharpe's model. Number one, single security. Number two, portfolio of securities. Okay, number one, single security. Number two, portfolio of security. First, we are going to cover for single security. Next, we will do it for portfolio of securities. Portfolio of securities is only a 10 minutes extra discussion. Single security, if you understand, portfolio security is just a weighted average. So therefore, problem is not with the portfolio of securities in the Sharpe model. It is about the single security concept. Okay, once you understand the single security angle, you can easily understand the portfolio because I will derive the formula at every stage. Okay, so I repeat once again, we are going to start with the most difficult area of portfolio called as a Sharpe's single index model. This 1 hour 15 minutes lecture will change your entire opinion formed on Sharpe's single index model. Easily you can gain 8 marks if comes in exam. Okay, let's start without a delay. Step number 1. So before going into that, sir, what is this Sharpe model? As the name suggests, Sharpe's single index model, it is very clear that this model assumes that in a country there is only one index, Nifty or Sensex. Both the indices are there. This model doesn't work. Okay, clear. Point number 1. So the assumption is a single index is the assumption of the model. Next, what it focuses on? This model focuses on regression analysis. This model focuses on regression analysis. Sir, what is a regression? From the statistics, the word regression has been imported. Regression means taking the past data and anticipating the future. Occurrences done in the past, assuming how it happens in future, itself we call as a regression. Okay, itself we call as a regression. Sir, I will tell you one example before we start. There is one person who will predict the future called as Nostradamus. Yes, he used the regression analysis. So regression analysis is statistics. We are the fools if we don't really understand what is regression. Don't see regression as some mathematical or statistical measure and put it away from the mankind. Regression is a simple concept of taking the events of the past and anticipating how they could repeat in the future is called as a regression. Regression is a concept where we will take the past events as a base and we will anticipate, okay, if this is happened in the past, in future how it could be. Some may be correct, some may be wrong. Like that share market is, like that our future also is. That means we have a wrong opinion or a correct opinion, leave it off. Nostradamus said something, it happened. Everything he said didn't happen. Like that, everything he said also didn't fail to happen. Some may happen, some may not happen, because his expectation also have a standard deviation. Really, they uses the regression analysis. Regression is a concept of analyzing the past data and understanding how it is going to impact your future. Okay, in this anticipation, you may go correct, you may go wrong. The chance of going wrong itself is random error in the model, which even Nostradamus didn't consider. Their model says that this will happen, may not happen. 2012 December, everything will end, nothing has ended. The day is more peaceful than any other day. Means you didn't give impact to the random error element. Random error element is some other factors which is affecting you, which I don't even consider. Sir, okay. Anyway, let us go into the stock market analysis of the Sharpe's single index model. Okay. Sharpe model is a regression analysis. Always regression means, keep in mind. Okay. Always regression means taking the past as a base and understanding how it is going to impact our future. Okay, when I tell regression, a comparison will be there between two things. Okay, comparison between two things, nature and mankind, nature and earth is the analysis made by him. Like that, share and the market is the analysis we are going to make. Here we are going to regress what? Here we are going to regress. Okay, here we are going to regress the share market. I mean to say our company share with that of the market, or security and the market. You can understand this more better. Okay, next. So, I will expect something. Guaranteed it will happen. Chance is there, may not be there. That means a risk is there or not. Risk here means what? In our portfolio chapter, okay, entirely portfolio chapter 20 classes I have taken. This is the 21st class. In 20 classes, what you have learned? Risk of a security means what? It is not about we are dying, we are falling, not that. Here the risk is what? Fall in the security return. Okay, or changes in the security return. Always return under portfolio chapter means which return? Expected return, also called as a mean return, also called as an average return. Okay, average means on an average it will happen. Means there is a deviation or not. So not getting the expected return itself is called as a risk. Okay, why we are expecting something and it is not happening? Because of two reasons. Number one, because of market effect, called as a systematic. Systematic risk means a risk that comes from the system. CMA model I analyzed it clearly. I am not going to reanalyze and waste your time. Unsystematic risk is the risk which is not coming from the system, which is your company specific. Means what? Bad management, oppression, mismanagement in your company. Okay, bad compromises made by your company, employee turnovers. Okay, goodwill is lost, frauds happening in the company. All these are unsystematic risk of a company. So when unsystematic risk is there, I will not pay any premium because it is your burden to change the company. Okay, systematic risk is the risk which you are performing well, but the market is making you to come down. For that, we will pay you the premium. Okay, so regression analysis means we will take the past, our company's information, past market information. From this, we are going to make a comparison how one going to influence another. Okay, what is regression? Regression means taking the past data. Okay, repeat, taking the past data and anticipating the future by taking the averages. For example, past data is given, we will make an average and we will expect that average to continue in future. But that average is guaranteed, unguaranteed, unguaranteed. So therefore, we will calculate the standard deviation, all these things. We will compare the share, our company share with the market, and we are going to analyze how the market is going to impact my company's share. Clear? Now, this is a basic introduction. Let us start with question number 31. See here, this is question number 31. Everyone in the study material also this question is there. Names may change. Okay, names may change. I am taking it from the past study material. There they use our JK Limited. JK Limited is a security. Okay, yes, it's a market M or X, Y. Anything you can take. So year 2002 average share price. Okay, average share price 242. 2003 279, 2004 305, 2005 322, dividend per share 20, 25, 30, 35. Market average index 1950, 1812, 1950, 2258, 2220. Dividend yield is given. Return on the government bonds is given. Compute the beta value of P Limited as at the end of 2005. Also find out CML for this security, means characteristic market line, not capital market line, and analyze the security variance as a systematic and unsystematic risk. Okay. First, initially when this question was asked, this was asked for 9 marks in exam. Latest exam, the same question was asked for 6 marks, because they asked only up to here. Remaining thing they didn't ask, they asked for 6 marks. Analysis of the security variance also, if they ask, they add another 3-4 marks to this. Okay, 2 bits they will ask for 9 marks. So first, I will give you only 1 minute time. Analyze the question properly. Once you analyze, I will start fastly with the discussing on the aspect. Okay, please make it fast. Completed? Okay. See here now. First, what we have to do? First, to analyze market and security, we should first calculate return of a security, return of a market for the last years. Okay. First, listen carefully. I will be making you certain points clear. After that, you can do. See here. Point number 1. 2002 year. Okay, 2002. For 2002, you want to know the return. Okay, how to calculate the return percentage for 2002? D1 plus P1 minus P0 whole divided by P0 into 100. What is the D1? 20 rupees. Plus what is the P1? P1 242. Minus what is the P0? Question mark. Didn't give. That means you can't calculate the return for the year 2002. In this question, you can start calculating only from 2003, because for 2003, 2002 is a base year. Like that, you need to understand the problem. Okay. Just because of the reason that 4 years information is given, that doesn't mean that you need to calculate return for 4 years. 4 years information is used to interpolate 3 years data. Okay. So for the 2003 year, everyone take calculator. Take calculator. Okay, make it very fast. If you complete this problem, I guarantee you, I promise you, once by the time we complete this particular problem, entire sharp model you will complete 1 hour 15 minutes. Give me, allocate this 1 hour 15 minutes time. In the exam, no question can come to corner you. Each and every angle of sharp model we will be covering very fast. Okay, take calculator very fast. So D1 is how much? 25. Don't take 20. D1 plus P1 279 minus P0 whole divided by 242 into 100. How much? 25.62. How I calculated? 25 plus 279 minus 242 whole divided by 242 into 100. For that 2002 information is given. Am I clear? So this comes to 25.62%. What I said, let's not waste time in calculations. Let's put more on the analysis. So like this, I have calculated already 3 years information. Okay, 2002, 2003, 2003, 2004, 2004, 2005. So 25.62, 20.07, 17.05. Okay, now up to here, if you want, you pause the lecture, write down the data. Okay, I'm giving 5 seconds gap such that randomly video should not go. Okay, you just pause the lecture, write down it. After that only you listen to the next step, but I will continue with the steps normally. Okay, next. Like security, we should also calculate the return given by the market. Return given by the market. When you calculate the market will be represented by index points. Market will be represented by what, sir? Index points. I already told you in capital asset pricing model. So now I am not going to repeat anything. Those who are listening only to the sharp model, I presume that you already know how the index will be framed, how these points will come, everything. Okay, with that presumption, let us start. And if you don't know that nothing will happen, it is not going to affect your understanding of SSIM. Okay, let's start. So average index, how much is the opening index value? 1812 for 2002. Means instead of valuing each and every share inside the market, we will allocate one point. Change in the point represents the change in overall market. Okay, so how to understand? Instead of D1, I will put I1. Sorry. Instead of P1, I will put I1. P1 minus P0 whole divided by P0 into 100. This is one part. If it is a company, I will get dividend in rupees. If it is not a company, if it is a overall market, one company may declare dividend, one company may not declare dividend. Therefore, the total dividend, listen to the words, or else you write on a paper. Total dividend declared by all the companies. Some company may declare, some company may not declare. 50 stocks are there in Nifty. In that 32 companies declare dividend during the year. Total all the dividends. Okay, total all the dividends. Okay, on the last date of the year. So total the market values of all the companies. Market values of all the companies. 50 companies are there. One company is having 1 lakh shares. Price is 100. So 1 crore rupees the market value. Like that, all the 50 companies total the market values. So total market value, total dividends. So total dividends divided by total market value is called as dividend yield. Dividend yield. Yield is always on market values. Okay, so that's right. Plus dividend yield percentage. Already they given in percentage. Na? You can't add because you can't add in the formula because it is not a price. It is given in percentage. So percentage should be added to another percentage. So I1 minus I0. Take calculator. I1 1950 minus 1812 whole divided by 1812 into 100. 7.62 plus dividend yield how much? 4. So total 11.62 it has become. So 12.62 it has become. So I1 is 1950 minus I0 1812 whole divided by 1812 into 100. One value will come. To that 5% you need to add. How much, sir? 5%. How much it became? 12.62. This one you need to add. I1 minus I0 whole divided by I0 into 100 plus the dividend yield of this year. So total it has become how much? 12.62 percentage. 12.62 percentage. This is a government yield. I mean, this one you need to add. So I1 minus I0 whole divided by I0 into 100 divided by plus dividend yield percentage on this. Okay, means 1950 minus 1812 whole divided by 1812 into 100. One value will come. Plus dividend yield percentage 5%. By mistake I have shown you this number because both are fine. I forgot it. So 5% you need to take. So total will be 12.62 percentage. Like that we need to calculate also for the next year. Please take the calculator. 2258 minus 1950 whole divided by 1950 into 100. 15.79. 15.79 plus 6%. 15.79 plus 6%. How much it is? 21.79. 21.79 market. So like that the third year, 2004-5. 2220 minus 2258 whole divided by 2258 plus yield is how much percentage? 7%. Okay. So don't consider these. By mistake I also consider those. So this one you need to consider dividend yield. Okay. So 7% we added. How much you get? 5.32. Now what are the informations that are available on hand? Tell me. What are the information that are available? We have 3 past years security return, 3 past years market return. Past or future or past. From the past data, we are now going to anticipate how the future used to be. Okay. Now listen carefully. Now we are going to establish relationship between market and the security. Not only just a relation establishment, we are going to understand how market is going to affect the security. We are going to analyze how the market is going to affect the security. Means how the market is going to influence the security is the thing we are going to do. Okay, so how the market is going to influence the security? That measure is called as a beta. That measure is called as what's a beta. But beta that is calculated till now, if you observe, sigma s by sigma m into RSM beta. Covariance of SM divided by sigma m square beta. Delta SR by delta MR means a change in security return by change in market return beta. Like that, so many beta calculations we have done till now. But now we are going to calculate the beta using the regression equations. Using what's a regression equation? There are three formulae here. Any of the three you can use in examination depending on the information given. But what I recommend you to do, also I will tell you during the course of your understanding. Okay, let us see. With the written information available, SSIM established a relationship between security and the market. Okay, security and the market. So tell me, market influences security, security influences market, market influences security. Influencer is the market, influenced is the security. Always remember, on a graph, influencer should be on x-axis, influenced should be on the y-axis. Okay, that's why in the formula he will use the word sigma xy. X means market, y means security. If you interchange, gone, don't mug up the formula, go by the logic of the formula. Okay, now let's continue. Okay, so the main point that we have to understand is y, influenced variable. So therefore it will be coming and falling on the y-axis. X, influencing variable, which comes and fall on x-axis. M is what? Slope. Slope or level or degree of influence. Who is influencing? Market influencing. Influencing whom? Security. How much influence is there? What is the magnitude of its influence? We will understand through a slope. Okay, we will understand through a slope. C is what? A constant. C is what? A constant. Okay, next. Summary of market and security return. Summary of market and security return. Year 1, 2 and 3. Market x-axis, security y-axis. The information whatever we have gathered there, I have again summed up here. Year 1, year 2, year 3. Year 1, market has given 12.62, security has given 25.62. Like that, all the 3 years, 3 different returns are there. When market is at 12.62, you are 25.62. When market is at 21.79, you are standing at 20.07. When market is at 5.32, you are at 17.05. Using the above information, we will calculate the beta. For analysis sake, we use all the available beta formulae. Sir, for understanding sake of my students in the class, I have done for this problem beta under all the models available. But in exam, you need to do regression type. Okay, I have done all kinds of beta. Okay, whatever the beta is done till now, every model I have used here. Okay, like what? See here. Step 4, calculation of beta. I used the following models. See here, way number 1 of calculating the beta. Way number 1 of the calculating beta. Covariance of SM divided by sigma m square is there. So means what? Covariance of xy divided by sigma x square. Yes or no? So the same formula I have used. Instead of SM I put xy here. Okay. So covariance of xy. How to calculate this? Sigma x minus x bar divided by y minus y bar divided by n whole divided by sigma x means what? This sigma x means what? Sigma x minus x bar the whole square divided by n the whole root. Whole square means what? The square and this get cancelled. This is how it will remain. Okay, sigma x minus x bar the whole square divided by n, both will cancel. Therefore, instead of separately calculating covariance, you can just use the formula x minus x bar. This is the first one. Y minus y bar. This is the second one. Multiply and aggregate both of them. This is the third one. Sigma x minus x bar the whole square. That's all. We can directly do the formula. So, market information average is 13.24. Okay, market has given a total return over the 3 years of 39.73. Average happens to be 13.24. This is a total return, average return. Okay, first year is how much? 12.62, but average is how much? 13.24. That means the average what we calculated is having a deviation from the actual information you have taken. Okay, what is the standard deviation? Minus 0.62 for the first year, 8.55 for the second year, minus 7.92 for the third year. minus 7.92 for the third year. From the first problem onwards, I have been telling this. Always when we calculate a mean is an average. Okay, average may happen, may not happen. Average may happen, may not happen. Therefore, from the average, what is the deviation that we are going to get itself, we are calculating using a measure called as standard deviation. Okay, standard deviation. That means average means it is not in this extreme, it is not even in this extreme, it is somewhere in the center. Okay, that's why it's called as a measures of central tendency. So from the center, it can either move this side, it can either move this side, it can either add, it can either deduct the value. So 13.24 is an average, So there is a deviation for this. Sir, where we calculate a deviation? In this formula, we don't require deviation because directly we are using sigma x minus x bar into y minus y bar divided by sigma x minus x bar the whole square. So I applied the formula and I got the beta as follows, 0.15. This is way number 1. If you want, you pause the video and note this answer. Way number 2, I will use beta equal to sigma s by sigma m into RSM. S means y here, means security is on a y-axis, market is on the x-axis, sigma y by sigma m into RXY. RXY means first we need to calculate correlation or not. So for that we need some information. See here, what I have done. Year 1, y minus y bar the whole square. Y minus y bar the whole square is this one. I calculated standard deviation 3.55. Okay. Calculation of correlation, covariance of xy divided by sigma x into sigma y. How the covariance can be calculated? Sigma x minus x bar into y minus y bar, 20.47 divided by 3, 6.823 or 6.8233. Okay, divided by 6.74 into 3.55. So correlation happens to be 0.285. When correlation is obviously positive number in this case, okay, plus 0.285. How to interpret plus 0.285? How I said the correlation concept? Correlation means how market and security is going to move together. Okay, how market and security is moving together means what? How much strength is there in the co-movement? It's a positive correlation, means security increases, market increases, security decreases, market also decreases, or market increases, security increases, market decreases, security also decreases. How many times this relationship is true? Market increase, security also increase, market decrease, security also decrease. How many times this relationship is true? That means 100 times whenever market increase, security also increases. No. In 28.5 times out of every 100 times, this relationship is true. Means what? Market increases, security will necessarily increase. No doubt. Market increase, security will necessarily increase. Okay, no doubt. Security will also increase. But how many times? 28.5 times out of every 100 times. Means the impact of this influence, or the both of them moving together or moving backward or forward, is true in all the cases. 28.5 times out of every 100. 28.5 times out of every 100 only it is true. Means what? Means they are weakly correlated, positively correlated, but they are nearing to 0. Okay, that means out of 100 events, if you take 100 events, 100 events are 28 to 29 times market and security move together. Together means what? Increase and this also increase, decrease and this also decrease. Then remaining times, no correlation. It doesn't mean negative correlation. No correlation in the remaining 72 times out of every 100, out of 70 to 71 times of every 100, both are randomly moving each other. Sometimes it will increase, it will decrease. Sometimes it will decrease, it will increase. Sometimes both move together. Sometimes there is a market will be standstill, but the security will be increasing and decreasing. Means in 72 events out of 100, market and security correlation is not there. Okay, market and security irrelevant. Market is increasing, this is standing still. Market is decreasing, this is standing still. There is no correlation between them in 72 events out of every 100. Okay, 28 times now both move together. Means their movement for every 100 events is higher or lower. If it is more than 0.5, nearing 1. If it is less than 0.5, nearing 0. That means 28.5 means what? It is almost nearing 0. Okay. Calculation of beta. Beta equal to sigma y by sigma x. What do you mean by that? Sigma s by sigma m into RSM. Okay, 3.55. Again, beta came to 0.15. In this model, beta is how much? 0.15. In this model also, beta is how much? 0.15. Next, way number 3, way number 4. These are regression equations. Examination, whenever they ask you to calculate beta, maximum possible use these only. If they give correlation etc. in the question, then you go by the previous models. Correlation not given. If they give information like this, they are expecting you to do beta calculation like this. If they give information about sigma s, sigma m and ask you to calculate, use that model. If information is barely given like this, okay, bare information is given, that means you only have to calculate everything now. Follow this model only. Study material and suggested answers and the key represent answer using this model only. Okay, what is this? Let us see. Two models are there, either this or this. Okay, either this or this. Okay, beta equal to sigma xy. Sigma xy. It's not sigma x into y. It is a sigma xy. So how to understand this? Don't commit mistakes. Like this you need to understand. Okay, that means, it is xy sigma. First, x means what? Security return, market return. Y means what? Security return. Both multiply, called as a sigma xy. Minus n. N means number of population. Here 3 we have taken. Past data, how much you take? N. Into x bar means average of market return. Y bar average of security return. Multiply. That means you should multiply the mean of market, mean of security and multiply into the population. 3 divided by sigma x whole square illa. X square ki sigma. Okay, x square sigma. X square means what? Square of all the market returns, total them. Minus n, x bar the whole square. X bar will come like that particular thing square. Or fourth way, beta equal to n sigma xy. Okay, n sigma xy minus sigma x into sigma y. Whole divided by n sigma x square minus sigma x whole square. Okay, these are the two formulae. So you please copy by pausing the video. I will tell you the derivation of the formula as well. Okay, so let's start. Okay, way 3 and way 4. So first observe the formula. Derivation, everything I will tell you. Okay, derivation, everything I will tell you. First, way 3 and way 4. Hope everyone understood, right? First, you need to remember the formula. Once you remember the formula, if I tell some derivation, you can really digest and try to understand. Okay, so first, see here how this fourth formula came, way 4. Third formula is there, na? Beta equal to sigma xy minus nx bar the y bar whole divided by sigma x square minus nx bar the whole square. Okay, now listen carefully how they have done this. What they have done first is, okay, whenever we take this particular formula, okay, whenever we take this particular formula, let's elaborate this. I will write this way. See the screen, everyone. Sigma xy minus n. X bar means what? Sigma x by n. Y bar means what? Sigma y by n. Whole divided by sigma x square minus n. X bar the whole square means what? Sigma x square divided by n square. Yes or no? That's the meaning. Sigma x by n whole square means a by b whole square means what? A square by b square. Totally we will take na. So divisible rule. So this is how we can do this. Okay. So sigma x the whole square divided by n square. Okay. Now multiply n in the numerator and denominator. N sigma xy minus. If you multiply by n, what will happen? N is already there. N into n become n square into sigma x sigma y whole divided by sigma x square minus n sigma x square minus n square into sigma x the whole square divided by n square. N square cancel here. Clear? N square cancel here. Here also sigma x sigma y whole divided by n square will be there. This n square and this n square will be cancelled. n sigma xy minus sigma x sigma y whole divided by n sigma x square minus sigma x the whole square. That is how this formula has been derived. Clear? So n sigma xy minus sigma x sigma y whole divided by n sigma x square minus sigma x whole square. That's how this formula has been derived. Sir, okay sir. Now what you have done? How the formula number 4 has been derived, you explain sir. Then how the formula 3 has been derived? Because formula 4 you have taken 3 as a base. But how the 3 has came, that we are going to analyze now. Okay. But before going into that, this is how I have done the derivation also in the notes. Clearly I have given step by step analysis. Okay. Next. So that's why I have clearly written derivation to formula 3 will be using simultaneous equations explained later. Okay. Now what we are going to do now, next stage, beta calculation using that particular model. Way 3, way 4 we will calculate beta. First listen. Sigma xy means what? Xy ki sigma. This is x, this is y, this is xy, this sigma. So therefore sigma xy is 851.36. First over. X bar y bar. X bar y bar. Already we calculated in the previous formula. Okay. So x bar y bar. N into x bar y bar. So n 3, x bar 13.24, y bar 20.91. Okay. X square 12.62 square, 21.79 square, 5.32 square. Okay, you have done this. So x square ki sigma, 662.36 minus 3 into sigma x the whole square. Sigma x means what? 13.24. Sigma x means what, sir? 13.24. 3 into 13.24 square. So 20.81 divided by 136.47.515. Again the beta is same. Okay. You can calculate beta in this way. Also you should calculate only in this way, by the way. Okay. You should calculate in this way only. There is no second model around it. Okay. You should do only in this model. If information is given barely in the following format, rather than using correlations, marks will be given if you do in the regression model. And this is more easy also if you remember the formula. I already told you the derivation. Sir, you told derivation not for this sir to the way number 4. This derivation also I will tell you now. Okay. See there. 0.15 is the answer. Way number 3. Sir, way 4 sir. Way 4 also we will do. Okay. N. Sigma xy already we had. Sigma x 39.73. Sigma y 62.74 whole divided by n sigma of x square. X square ke sigma 662.36 minus sigma x 39.73 whole square. Again we got the same answer 0.15. Hope everyone is having a full clarity up to here. With this we have completed first part of the answer. Okay. Let me consolidate everything whatever we have done till now, and then we will go into the next stage of the discussion. Okay. So first what we have done, we have taken the past raw data available. With that we calculated the returns at each level. Okay, returns at each level. Once we calculated the returns at each level, we have then made a comparison between them. After that, we calculated beta using all the models available with us. We used covariance model, we used correlation model, we used way number 3 regression model 1, we used way number 4 regression model 2. All the models we have done. In 4 models we have done the beta. Beta answer is same. Why I have done beta in all the ways? Everyone may get a question. Sir, when answer for beta in all the cases is essentially the same, why you are using this model? First model also giving the same answer, second model also giving the same answer, this model also giving the same answer. Then why I have to follow this model instead of going by that model? Question will arise, yes or no? This question will be answered at the last stage of SSIM, because you will really understand the impact of the Sharp model when you come to the portfolio analysis, not just one security analysis. Okay, if you saw individually as a security, maybe all those models also will give the same answer. But when you go into the portfolio analysis under the Sharp model, then you will really realize the importance of Sharp single index model, why people always prefer this. Clear everyone in the class? So this is the first part of our discussion. I will put my discussion in 3 parts totally. Okay, 35-40 minutes lectures. Okay, 40 minutes and 40 minutes. Once you put stress on that, enough. I told you maximum 1 hour 15 minutes to 1.5 hours max. We'll complete entire sharp model. One part of the sharp model has been completed with this. Clear? Later what we are going to start? Relation establishment of relation. Not just normally, we are going to analyze in depth about how the simultaneous equations has to be drawn and how the sharp model will calculate these. Lastly, we will find a systematic and unsystematic risk bifurcation and coefficient of determination. Everything we will do. Okay, one by one in parts, bits and pieces, we will do that. Clear, everyone? Thank you. So next part number 2, will be covering out the concepts regarding the market and the security establishment of a relation. Okay. So let us continue. In the first lecture, what we have done is we calculated beta. Beta using one model? No. 4 models we have used beta. Means we are using 4 models in order to calculate the beta. Essentially, the answer through all the models is same. So as I already shown you, first we have calculated using, we have taken the information of the market and the security. Using the market and the security information, we calculated beta using covariance model. Covariance model is the model we are seeing here. So using the covariance model, we have first calculated. After using the covariance model, we have then came to standard deviation of security by standard deviation of market. Means we have taken the correlation method. As per that also, we got the answer as 0.15. Okay, beta is 0.15, correlation is 0.285, but beta is 0.15. What is the meaning of 0.285? Both the security and market are positively correlated, no doubt. But how much positive? 0.285 means if the market increase, security also increases. But 100 out of 100 times it is true. 28.5 times in every 100 times it is true. But the remaining 72 times what will happen? They are not correlated with each other. Means it is not responsive to the market. Okay, so least correlated. Okay, weak correlation, scattered points. Okay, it is widely scattered, not closely scattered. It's a widely scattered thing. Okay, next. Way number 3. These are called as a regressed equations. Okay, regressed equations through if you solve, you will get this particular answer. Sigma xy minus nx bar the y bar divided by sigma x square. That means this is a x square ki sigma minus n x bar the whole square. Way number 4. N sigma xy minus sigma x sigma y whole divided by n sigma x square minus sigma x the whole square. Solved it. Fourth formula derivation also I have done. We have solved the formula number 3. We got the answer as 0.15. We have also solved the fourth formula. We have also got 0.15 in that case. In all the cases, beta is 0.15. Okay. Now question. Sir, in exam question comes na, we have to do all these things. What I told you. First step is common here. You have to do this. You have to do this. You can't escape these 2 steps. This is common. Once you do this, directly you can go to any of these 2 formulae. Means either go by way 3 or either go by way number 4. You choose any of the ways which is more comfortable you feel, and you choose that and you go with that. Okay. If you ask me, sir, what I should do, go by way number 4. Way number 4, mean will not be there. What will not be there? Mean will not be there. Again, x bar, y bar means you may forget what it is. So therefore, to avoid that particular chance, you select way number 4. It is easy. Just it's a totaling. Okay. But always remember, x represents a market, y represents a security. Don't interchange them. When I call x, x means x-axis variable. Y means y-axis variable. Therefore, market is a variable, a constant, a variable. But this variable influences another variable called as a security. Therefore, influencing variable is x, influenced variable is y. Means influencing variable will be on x-axis, influenced variable will be on y-axis. Market will be on x-axis, security will be on y-axis. Okay, that's the meaning behind this particular concept, right? So let us now continue with the remaining parts. Derivation we have seen, and we have calculated derivation, and using these 2 models, way 3 and way 4 also we have done. Okay, now listen. Whether exam oriented, whether normal, leave off, first we have to understand one point. Sir, why sharp single index model I have to do when beta answer is same everywhere? is a question. Okay. Till now, whatever the models that you have seen, all the models, okay, whether sharp single, sorry, whether CAPM model, CAL, CML, or APT, any model you take, they analyzed systematic risk and unsystematic risk. Sharp has clearly said how much amount is systematic, how much amount is unsystematic. Okay. If I tell like this, people may not understand. From here, listen carefully to the discussion such that you will not break the flow of understanding. Exam you should not commit mistake. If that is your intention, next 15 minutes is for you. If you understand the next 15 minutes in a proper way, never you will commit mistakes with regard to the Sharpe's single index model. Okay, let's see. Establishing relation between market and security. Establishing relation between market and security. Okay, now even before we do this, I will give you one example just to make you understand. See here. I will draw lines. Okay. Now see here. I have drawn 3 lines. What is the meaning of this line? What is the meaning of second line? What is the meaning of third line? I asked. What is the meaning of the first line? What is the meaning of second line? What is the meaning of third line? I don't know. Why? There is no meaning for a line unless it is drawn on a graph. Now tell me, what is the meaning? What is the meaning? What is the meaning? First one, when x increases, y is also increasing at a same trend. When x increases, y is overreactive and increasing. When x is increasing, y is increasing at a lower trend. That means a line will always explain the magnitude of relation between two variables. So don't underestimate mathematics. Midpoint formula and y equal to mx plus c. That's the origin of entire mathematics life. Always a relation between any two persons can be understood using a straight line. From that only linear equations, curvilinear equations, okay, hyperbola, parabola, all these concepts came from relation of two variables. Hyperbola, parabola only later modified into a what mathematical calculus with the name called as a derivatives, okay, or derivations. dy by dx we will do now. That's a mathematical calculus. So which is developed from the parabola, hyperbola concepts. After that, they want to establish a relation between variables, how one will impact another. Okay, that's how they started developing the derivations under mathematics. A person from a mathematics background, let me tell you one thing. Mathematics, a straight line will be having a great meaning because straight line will always establish a relation between any two variables. Okay, any two variables, it always establishes a relation. Okay, so normally line have no meaning, but if it's drawn on a graph, how much one variable is influencing another is very clear from that picture. Okay, so therefore always straight lines are will represent relation. Straight line will represent what's a relation. Okay, now listen carefully. This is a graph, second one is a graph, third one is also a graph. Now I will tell you one thing. See here. X, Y, market, security, market, security, market, security. First example, if the market increase by one time, security also increase by one time. Equally, both are moving. Okay, next. Market increase by one time, security move by 2-3 times. Beta is very high. Market is increased by one time, security increase by 0.25 like that. Beta is very low. Like in the present case. In the present case, what is the beta? 0.15. Means what? When the market changes by 1%, my security will change by 0.15%. Okay, 0.15%. Or if market raised by 10%, I will raise by 1.5% only. That means I am overreactive to market, equally reactive like market, least reactive to market, least reactive to market, least reactive to what's our market. Okay. So that's the answer that we can put out. Listen carefully to the logic. So always, what is a straight line? Straight line will always establish a relation. Straight line will always establish a relation. If you see, I have drawn 3 graphs. Roughly I am drawing. Okay. 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 3 graphs I have drawn. Now if you observe here, line first situation la, line is having a nature like this. Means what? If you see, whenever the market rise, security also will rise. Market rise, security also rise. Market rise, security also rise. From this, what you have to understand, what is the difference? Everything is a straight line only. First is a straight line. It's a points which are plotted and which are drawn as a line. Second also plotted points. Third also plotted points which are joined. Second is a plotted points joined. Third is a plotted points joined. First one is a straight line. Second one is a straight line. Third one is also a straight line. First one is a graph. Second one is graph. Third one is also a graph. First one la x-axis la x, market, y-axis la security. Second also same, third also same. That means graph same. Taken the variables are same. Plotted points are same. Everything is same. But what is changing here? Slope. One is having this slope, another one is having a steeper slope. Okay, first one is having a moderately steep, second one is having a blunt, third one is highly steep. Means what? The slope is changing. What is changing, sir? Slope is changing. If the slope is like this, what does it mean? How much market increases, security also increases in that same way. Equally reactive. Slope is constant. Okay, slope is constant or slope is equal slope. Second one, least slope is there. Means what? Slope is very less. Slope is very less. Market is reacting, but I am not reacting to the market in an equal way. Okay, sir, this line if you observe, almost it is becoming constant. So if some time after now, it will run like a normal line. Okay, so therefore the slope is very low. Here the highest slope is that. Like this the slope is. From this what you have to understand, slope determines the nature of impact of the variable influencing and the nature of how the other variable is getting affected. Means affecting variables impact on another variable is always called as a slope. I repeat, slope means influence of influencer on the influenced. How much it is going to influence is called as a slope of a straight line. Slope always determine influence of one variable on another variable. Understood the point up to here? That slope itself is y equal to mx plus c. Slope is called as m. What is x? Influencing variable. What is y? Influenced variable. What is c? Constant. Sir, what is this constant? That's called as a constant intercept. I will explain every point very clearly as if this is a mathematics class. Okay, I am playing the role of two faculties. For that you should be cooperative. So please listen carefully to the words very clearly that are used. Sharp model is based on stat and mathematics. Okay, that's why sharp model is very confusing. That's why the thumbnail of this is also, are you confused with sharp model? Listen to this lecture. Okay, so listen carefully. So the point is y equal to mx plus c is a game changer in the model called as a Sharpe's single index model. Okay, now establishing relation between market and security. From here I have taken different example. Problem will start soon. Let us consider following information. Example I have taken. X 1%, Y 3%. X market increased to 2, security increased to 5. Market increased to 3, security increased by 7. You should only tell. Here what is the change in the market? 1. What is the change in security? 2. What is the change in the market? 1. What is the change in security? 2. Now tell me the slope is always constant, different slope, Constant slope we are seeing. What slopes are? Constant slope. Constant slope means what? Whenever market change by 1, this is also changing by 2. Means what does it mean? R equal to plus 1. Correlation perfect. Okay, correlation perfect means what? What do you make correlation perfect? Market move, security also move to the same side. Market come back, security also will come back. Okay, how many times? 100 out of 100 times it will happen. 100 out of 100 times. But how much influence market is showing on security? For that, correlation will not be useful. For that, we need to calculate the regression. Correlation will tell nature and nature and the validity of the statement of nature. Means what? Covariance will always tell. What will? Covariance will always tell whether both are having a negative or positive correlation with each other. That's why correlation decides the symbol. Correlation decides what's a symbol. Whether negative or positive will be decided by covariance. Correlation will tell the truthfulness of that relation. If covariance and negative come, negative means what? If one move further, another move backward. But how many times it is true? That will be said by correlation. Okay, that will be said by correlation. How many times it happened? Correlation. Therefore, three things you need to understand. If you don't understand the three things, na portfolio chapter confusion. Covariance will tell the nature of relation. Covariance will tell the nature of relation. Correlation will tell truthfulness of this relation. Regression will tell impact, the influence of one on another. Okay. Market move forward, security move forward. Nature is positive. How many times this is true? Correlation. How much market influences security? Regression. Okay. Regression. Now, market and security move together. Market move forward, security will move forward. It's an assumption of all the models. Okay. Okay. Now tell me, what is the nature of relation? Positive. Means perfect positive. May not be perfect positive. Positive, that's all. Okay. Positive. Okay. That means when market move forward, security also move forward. Yes. How many times? For that correlation. Correlation between what? Security and market. Okay. Okay. Now we understood correlation. Now, how much the market is influencing the security? That means when market move, you will also move for these many times. In the 28.5 times, how much influence market is showing? For that regression. Regression is calculated using beta. Okay. Regression is calculated using what's a beta. So year 1, year 2, year 3. I have taken 3 years of information. Here, market one time increase, security 2. 1, 2. Means when market increase by 1%, security increase by 2%, always there is a constant slope. In this case, you need not calculate beta using any other information. At that time, first beta formula we have done delta SR by delta MR. You can use that. What is the delta SR? 2. Delta MR? 1. If you take these two, delta SR2, delta MR1, delta SR2, delta MR1, 2 by 1 is how much? 2. So beta is 2 times. Okay. So Y equal to MX plus C. Okay. Y means what here? Security return. Also we call as KE equal to beta X plus alpha. Alpha is a constant. X means market. Okay. Y equal to MX plus C. Beta M plus alpha. You can write like that. Beta X plus alpha. Instead of writing like this, you can write M beta plus alpha. Anything you can write. So just example sake, I am writing this. Okay. Na? So influencing variable is M. Okay. Beta into M or X. Beta into X. Anything you can take. Therefore, when slope is constant, means the same across any information, points will automatically fit into a straight line like this. See the graph. See this graph. I plotted the points. Automatically points are fitting into a straight line. So when the points automatically fit into a straight line, we should understand that the slope is constant. Slope is constant. Means correlation is perfectly positive. Means what? Market increases, na? Yes. Security increases, yes. So correlation is what? Positive. What symbol is what? Positive. How many times? 100 out of 100 times. 100 out of 100 times it will be true. Therefore, line goes like this. But how much slope should be there depends on what is the influence of market on security. For that, we calculate beta. For that, we calculate beta. Sir, can you more refine this concept? Yes. Yes. I can tell in a best possible way than this. Okay. Market, security. Covariance will tell line should be like this or line should be like this. Okay, na? If it is a negative, line like this. If it is positive, line like this. In all kinds of models except APT, beta is assumed as positive. Means what? When market move, security will not move anti. Okay, market move forward means you also move forward. But with how much extent you will move is an entirely different story. For that only we are calculating all these things. Okay. So security, market move forward. Security will also move forward. Okay. That means one thing we understood. Line will be like this. Means like this. Line will be. Okay. Now you should answer. Line should be disa. Line should be disa. Will be decided by, that means line should be towards the origin, line should be away from the origin. Who will decide? Covariance will decide. Nature of the line, covariance will decide. Like this, decided by covariance. Am I clear? Okay. Now, so that will be decided by covariance. Now next, whether it will be like this or like this, it will decide. Whether it is a curve or straight line will be decided by correlation. Okay, correlation. Straight line or scattered points. For example, points are, okay, I will do one thing. Okay, here how the line is. Nature of line is like this only. But my point is, can you join all these points using a straight line? No, you can't join. So it will become a line like this somewhere. Okay, that's why always if you see in the market, it will be a graph like this because you can't correlate any security so perfectly in the real life scenario. Therefore, market will be like this always. Okay, it will be ECG. So here we can understand one thing. Relation is positive. Covariance will decide that. Whether line should be like this, it will decide. But all the points are fitting a straight line. No. All the points are not fitting a straight line. Means what? Correlation is positive. The covariance is positive. But the truthfulness, I said they are positively correlated. 100 times. No, not 100 times. So 28 times out of every 100. Means 28 times only they will move like that. Remaining time they will scribble around that particular. So therefore it will be scattered points. Okay, if the correlation is a 0.5, scattering points will be deep. Okay, densely scattered. If it is 0.7, much more densely. 0.9, almost dense. 100% if one straight line will be formed. So correlation will always decide, okay, whether the points are scattered or points are forming a straight line. Okay, who will decide? Correlation. Okay. So nature of line is decided by covariance. Means positive like this, negative like this. Okay. So nature of line, but whether to form a straight line or a scattered points will be decided by correlation. Will be decided by correlation. Now scattered points are there. Okay, what are they, sir? Scattered points are there. Scattered points will just tell us how one is having a positive correlation with another. But what is the influence of market on security? It is not decided by covariance. It is not even said by correlation. That the impact of market on security will be decided by an element called as a beta, also called as a slope. Also called as a slope. Means covariance will tell the line how it should go. Away from origin, coming towards origin, it will tell. Okay. So correlation will tell whether it is a scattered or a straight line. Beta will tell whether line is like this, line is like this, line is like this, will be decided by whom? Beta. Will be decided by beta. So covariance, correlation, and regression are the three elements that are widely used throughout this concept called as a Sharpe's single index model. Okay. So from this, what is the moral of the story? If there is a constant slope for given information, points will automatically fit into a straight line. You need not put any additional effort. Automatically, they will fall into a straight line. Okay. 1 point over. But in our given information, how they are? In our given information, year 1, okay, market is at 12.62, security is at 25.62. Market is at 21.79. Security stands at 20.07. Market is at 5.32. Security is standing at 17.05. Okay. Now tell me, normally take a calculator. Just a minute. I think I don't have. Just a minute. Okay. Have it. Take now. See the difference between 12.62 minus 21.79, 9.17, 9.17. Next, 25.62 minus 20.07, 5.55. These two differences. Next, 21.79 minus 5.32, 16.47. 20.07 minus 17.05, 3.02. Now, the trend is regular, irregular trend, irregular trend here. Both are not having the same slope. Market is changing randomly. In this case also, I want to establish a relation. I want to establish what's a relation. Okay. From here, Sharp model has taken a different shift of understanding. So please listen carefully. Take some time to understand. Okay. Listen carefully. So what happened in this particular model of Sharp? What he has done is, he has taken year X and Y as a base. He has taken this particular set of information from this question. We plotted on the graph. We plotted on what's our graph? Okay. First, 12.62 and 25.62. 12.62 and 25.62. Somewhere here. We plotted. Next, 21.79. 21.79. Don't go for accuracy here. Okay, we are not doing any statistics here. 21.79 and 20.07. Somewhere here. Okay, we done. Next, 5.32 and 17.05. Somewhere here it is. Okay, here. Now, if you observe, when the market information and the security information are plotted on a graph, they automatically fit into a straight line. They are forming a scattered points. That means they are forming a straight line. They are automatically fitting into a straight line, or they are scattered. They are scattered. They are what's a scattered. Once the information there is a scatter, if the points automatically fit into a straight line like this, I can tell that market increases, security increases. Okay, market increases, security increases. How much? On the basis of the slope. Okay, in the previous example, 1, 2, 1, 2 means what? 2 times I can establish a relation. Market influences security by 2 times, I can tell. When, if there is a constant slope. Now there is a constant slope or no constant slope or no constant slope, because the points are not automatically fitting into a straight line. They are scattered. They are scattered. Information 3 years are given, 5 years are given, much more easily you can understand this scatter. 100 informations are going to much better you can understand. Okay, so the scatter is very deep, the influence will be very hard. If the scattering is very vast, then the influence is very low. How deeply they are scattered, that much correlated they are. I think everyone now understood what is a correlation concept. Okay, so the point is, all the 3 points are all the 3 points are scattered across the chart. Scattered across what's a chart. So therefore, we can't easily establish a relation, because what I said at the beginning, always a straight line will tell relation of 2 variables. Here can I draw a straight line? So this is not a straight line. This is not a straight line. This is only joining the points. If I draw a line like this, it is not joining them. If I draw like this, none of the points are touched. If you draw a line like this, none of the points are touched. Okay, that means, can you attach all the plotted points on the graph? You cannot. Okay, that means these points don't form a straight line. When you can't draw a straight line, you can't establish a relation between 2 variables. To establish a relation between 2 variables, here market and security are 2 variables. One is an influencing variable, another one is an influenced variable. To establish a relation between 2 variables, I require a straight line. But here I can't draw a straight line. Therefore, there is a artificial line that will be drawn. There is what line, sir? Artificial line we will draw. That artificial line we draw itself is called as line of best fit, also called as a regressed line. Regressed line. So this is called as a line of best fit. Line of best fit. Okay. Line of best fit is a regression line which is a representative of all the plotted points. See here. If I draw a line like this, it is wrong on a higher side because all the plotted points are below that. If I draw a line here, it is always wrong on a lower side because all the points are above the graph, above the line. I should draw a line in such a way that it should exactly cut all the points in the middle exactly like this, such that some points will be above the line, some points will be below the line, both will set off with each other. If I tell like this, no one will understand. Just in another 15 minutes, you will really understand the beauty of the sharp single index model with this line of best fit. Okay, so let's try to understand this. I repeat for one more time. To establish a relation between two variables, we require a straight line. To have a straight line, all the points should plotted on a line, in a sequence. If the line plotted points are, I can establish. But always, how can you expect market and security to have a sequence? Okay, it will be like a ECG. Okay, but from that also you should establish some relation. How? How is it possible? When you cannot draw the straight line naturally, artificially draw a line. How can I draw like this? No, you can't draw a line like that because if you can't draw like this because the line is wrong on a higher side. That means none of the points are there above and below. It is somewhere going above the sky. You can't even draw a line like this because it is wrong on a lower side. If I draw a line which will cut the points exactly in the middle, then that particular line will have some points above it, will have some points below it. Both will set off with each other. How that set off will happen? We will see now in this particular case. Up to here, everyone understood? That's the beauty of the sharp model. Let us see from here. The story will be continued from here. Listen carefully. That means you will draw like this directly. That line we will calculate now. That line is called as a line of best fit. Line of what's a best fit? Okay. That line of best fit, we will get the points again. When you draw on a graph, automatically they will cut the points in the middle exactly. The beauty of the model you can understand once we all calculate the line of best fit. How the line of best fit has to be calculated itself is the next point we are going to discuss. Right? Let's see. One can understand that points are scattered. So we can't draw a straight line attaching all the plotted points. So we need an artificially created straight line which cuts all the points exactly in the middle. That line is called as line of best fit. Line of best fit. Line of best fit is a regression line which is a representative of all the plotted points. Okay. Straight line equation is y equal to mx plus c. To know a straight line equation, we require m. M is called as what? Slope. C is what? Constant. T defines where the line starts and M defines the steepness of the line. Means a line starts from here and it go like this. This steepness is called as a slope. This plotted point here is called as a constant. This is called as what's a constant. Why is this called as a constant? For 0 also it is giving na. 0 is a constant always. 0 don't change na. So therefore, for no return in the market also, how much your security is giving is called as a constant. In our model, it's called as a alpha. Okay, everything I will explain. Sir, I could understand 50-50%, sir. All your doubts will be clarified. This is not a normal model, sir. Nobel Award model. Sharp single index model got a Nobel Award. If you can understand in one go why it becomes sharp single index. So, at the end, did you understand everything or not? You check that. Sir, here I understood 80%, sir, 20% clarity missing. Every question of yours will be answered at the end. No, sir, even after that, I have a doubt. Put your comments below. I will answer every question from your side. Okay, see here. Regression equations. What equations, sir? Regression equations. This model is called as the least squares method. Which method, sir? Least squares method. How these formula are derived? Okay, I will be discussing separately in a regular class. In the fast track session, don't ask me to derive these formulas. These are already derived in statistics. It has nothing to do with the financial management. Okay, so I will derive areas of our syllabus. Okay, Other statistical models which are the origin for this, I will not. I will do this in a regular session clearly. Okay. Now we are examination oriented. I will tell you the derivation of our financial management formula. There are two kinds of regression equation. There are how many, sir? Two types of regression equations. See that. NC plus sigma y equal to NC plus M sigma x. Okay, sigma xy equal to C sigma x plus M sigma x square. So C means alpha. Sigma y equal to N alpha. M means beta. Beta sigma x. Sigma xy equal to alpha sigma x plus beta sigma x square. Beta sigma x square. So like that we need to derive. Sorry, I will write it on a separate sheet formally for your understanding sake, and then we will be going into analysis. Sorry, I will first formally put it on the sheet. Okay. Now see here. There are two equations. Sigma y equal to NC plus. See here, what I have written, I am rewriting the same. Okay, NC plus M sigma x. Equation 1. Sigma xy. So you see there, sigma xy. C sigma x plus C sigma x plus M sigma x square. M sigma x square. Listen carefully. M sigma x square is x square sigma, not sigma x the whole square. Okay. Okay. Here, sigma y is same for us. Equal to N. C means constant. What is a constant in our financial management language? It's called as alpha. Plus M means what? Slope. Slope here is what? Beta. Beta sigma x. Sigma xy equal to alpha sigma x plus beta sigma x square. Equation 1 and equation 2. Equation 1 and equation 2. Common sense use. I want these two to get cancelled. Okay. To get those cancelled, what we have to do? First particular thing is there that this particular first equation. Okay, equation 1 is there kada? That equation 1, if you multiply with sigma x, this if you multiply with n, what will happen? Sigma x, sigma y equal to n alpha sigma x. So n alpha sigma x plus beta sigma x the whole square. Beta sigma x the whole square. Okay, next multiply second equation, first equation, second equation with n. N sigma xy equal to n alpha sigma x plus n beta sigma x square. N beta sigma x square. Okay. This is 2, this is 1. So 2 minus 1. How to do? 2 minus 1. Then n sigma xy minus sigma x sigma y equal to this, and this will cancel each other now. N beta sigma x square minus beta sigma x the whole square. Beta sigma x the whole square. Okay. Now n sigma xy minus sigma x sigma y. Okay. Sigma x sigma y equal to beta you have to set aside. How it will be? N sigma x square minus n sigma x square minus sigma x the whole square. So beta equal to n sigma xy minus sigma x sigma y whole divided by, okay, n sigma x square minus sigma x the whole square. This is how the formula has been derived. Clear everyone? So this is how that formula has been derived. N sigma xy minus sigma x sigma y whole divided by n sigma x square minus sigma x the whole square. Okay, this is how the formula has been derived. Okay, this formula is the origin. Okay, previously what I have done, I have taken the third formula and derived the fourth one. What they have done, instead of multiplying with n, they divided by n. They got n sigma x bar y bar, like that they got. Okay, originally this is a formula. Okay, sir, in examination now what I have to do, sir? If you see in exam, sharp model, if they give, they will do simultaneous equations. Okay, if they didn't ask anything about sharp model, but just they asked to calculate the beta, then they use this formula. Okay, sharp model means least squares model you need to use. No, nothing sharp model, just a calculation of beta. This one, they asked the calculation of beta, but they have given correlation information, everything. Then go with the original models. Okay, so depending on the model you need to solve in exam. That's why if you do beta in other models, they will not value. That depends on what question they are asking you, which model the question is asked. That's why portfolio theory is why we have given so much importance. The main point is doing the answer is not important in portfolio chapter. From which model they ask the question, that itself is becoming a challenge. Okay, sir. Anyway, keeping all those aside, we have two least square equations. Okay, equation 1, equation 2. Sir, why you derived this formula? Question will arise on that. Why you derive this formula? And I am not a mad fellow to derive this. You have to derive because in this model only we are going to do the problems now. Clear? How? Let us see now. So, what we have to do now, this is the information that is available with us. Okay? This is the information that is available. You will use least squares model. In question 31, the results are as follows. Okay, results are as follows. Sigma y equal to n alpha. Sigma y means total of y, means security return. N alpha, n means information, alpha means constant. 39.73 beta. Sigma x, so you can believe me, all these are informations which you have already calculated. See here, if you don't believe me, 39.73. Okay, na? Believe me, all informations are taken from the question A. No wrongs. So 39.73 beta. Okay, sigma xy, xy ke sigma, xy multiplied for that sigma, xy multiplied for that sigma, 851.36. Okay, next alpha, we don't know. Sigma x, 39.73, already you have done here na. Next x square ki sigma, 662.36 beta. So this is a 2. So 2 minus 1, 2 minus 1. Okay, multiply equation 1 with 39.73. Why you have to apply 39.7? 39.73 is the sigma x. That's why derivation la, if you know that we have to multiply it with okay, you have to multiply it with the sigma x, you will really understand what is sigma x here. So here you need to multiply with sigma x. I want this and this to cancel. So what you have to do? Multiply this with this and multiply this with this. So automatically first equation we need to multiply with 39.73, next equation with 3. Okay, take calculator. 62.74 into 39.73, 2492.66. Okay, 3 into 39.73, 919.19. 39.73 into 39.73, 1578.47 beta. Next, 851.36 into 3, 2554.08. 39.73 into 3, 190.19. Next, 662.36 into 3, 1987.08. So you got equation 2 minus 1. Beta is 0.15. Beta is 0.15. Here we can calculate alpha. Here we can calculate also what's our alpha. So calculation of alpha, substitute beta 0.15 in equation 1. You can also substitute in equation 2, nothing will happen. I substitute in equation 1. In this, you got a alpha as 18.93. From that, what you have to understand, alpha is also calculated with the same formula. He will ask alpha in the question. Don't use a different one. You will use only this one. So, this is how the least squares method. So, tell me the formula now. Sigma y equal to n alpha plus beta sigma x. Sigma xy equal to alpha sigma x plus beta sigma x square. You have to remember. Okay, you have to remember, or else marks will go. That's all. Take it for granted. Marks will leave. Leave the marks then. 8 marks, you will not get 8 marks. If the sharp model is asked in exam, use these simultaneous equations because alpha will be calculated simultaneously. Question la beta is asked, but correlations, everything not given in the question. Okay. go by the previous model, n sigma xy minus sigma x sigma y whole divided by n sigma xy minus sigma x the whole square. Use that formula. So nothing is a basic model, he has given the question. Then go back to the original model and do the normal calculation of correlations, etc. Okay. So now this is the calculation of beta. Beta is how much, sir? Here 0.15. So now in this model also we got the beta as 0.15. Answer didn't change. So first model, second model, third model, fourth model, fifth model, in whatever model you do, beta answer is always 0.15. Okay. So 0.15 you substituted, alpha is 18.93. What is alpha? Constant. Means what? Even though the market is giving zero return, my security will give 18.93%. If the market increases, security will increase slightly. That's the meaning. Clear, everyone? Okay. Now, up to here, one part of the discussion is completed. Hope everyone understood the logic clearly up to here. Hope up to here everyone understood the concept. Okay. Now, nothing we have done till now. Beta calculation is done again. Beta, how many models have we calculated now? 5 models we calculated. From this only this model came now. Means if you do this, automatically simultaneous equations are indirectly used. But institute expect you to write the simultaneous equations when you do sharp model, because sharp originally done these. So therefore, you should also expect the student to do the same simultaneous equations. Tell me what is the equations? Sigma y equal to n alpha plus beta sigma x. Sigma xy equal to sigma xy equal to alpha sigma x plus beta sigma x square. Okay. First equation, simple concept. Don't mug up. N alpha and alpha sigma x should be cancelled here. What to do? First one multiply with sigma x, next one multiply with n. That's our game over. Okay. So both have to be done, means multiply with the first equation with sigma x, multiply second. Sigma x is missing in the first equation, multiply with that. N is missing in the second equation, multiply with n. Over. Game over. Am I clear? So therefore, this is the answer, sir. So next issue. So after the 2 minus 1 equation, if you do directly, you will get the beta 0.15. So you substitute that, you will get the alpha. What do you mean by alpha? Alpha means the return which a security gave, even if the market has come to zero, is called as a return. That's a constant return. Okay, constant. That means even if the market gives zero return, my security will give some return. Okay, that's called as a alpha. Okay, now up to here we calculated beta. Hope everyone understood the concept also. Now starts characteristic market line equation. Very, very important from the exam point of view. Sir, in exams, what I have to do? I will come back just for reference sake. First, this is the first prima facie calculation here. Step 1. Okay. Next, you need to do step 2. Step 1 is market return for the first 3 years. Security returns for the security return, market return for the 3 years. Over. Using this information, you first calculate this one. Directly come to the simultaneous equations. Do this. For this, what is the information you require? For this, what information you require? You require sigma y. So in a table, you have to write sigma y. You need to write sigma x, xy sigma, x square sigma. That information you keep with you, straight away you calculate. So in 5 minutes, you will come up to this step in the real life exam. I have to explain here, the step by step I am explaining various calculations of beta. So 2 minutes you will take to calculate the first step. 3 minutes you will calculate for this step. Means 5 to 6 minutes we will come to almost 70% of the answer. Now we calculated beta. What is beta? Beta is the slope. Beta is the slope. Means what? Magnitude of influence of the market on the security is called as a beta. Beta, if it is 0.15, means what? Market move. Security also move forward. Security also move forward. But market is moving forward. How much security will move? 0.15% influence is there. Means market increased by 10. Security increased by 1.5% only. That means you are influencing me heavily, lightly, loosely you are influencing me. But influencing. Positively influencing. Correlation is positive. Relation positive. Correlation is weak. 0.285 correlation. Okay, but how much influence you are showing? That influence I want. How much influence? Slope. Because for a straight line to draw, we should not just have a relation. We should not just have the truthfulness. We should also have the impact. So for that impact will be introduced using a concept called as a slope. Okay, slope. Next one, characteristic market line. Sir, what is this? This is the next third step you need to do in exam. Sorry, first step security return, second step market return, third step beta, fourth step should be say characteristic market line in exam. Okay, leave about the problem what I am discussing now. Okay, this is exam question. 4-5 steps is for our understanding in the class, but in exam, fourth step will be characteristic market line. Very, very important. Listen carefully. Year 1, 2, 3. Return. Market has actually given a return of 12.62, 21.79, 5.32. Okay, 5.32. Okay, now I want to establish a relation between two variables. What I have to use? Straight line. What I have to use? A straight line. Straight line equation is what? Y equal to mx plus c. What is y? Influenced variable. Means security return, market return, return of a security. So, or return of a investment, he will call. Ri equal to, okay, mx plus c. M means slope. Slope here represents what? Beta. Mx, x means what? Influencing variable. What influences market or security? Market. Plus c, constant is what? Alpha. So, security return equal to beta m plus alpha. Instead of m, they will write rm, return from the market. Okay. Okay. Now, beta rm plus alpha. Tell me now, how much is the beta? We already calculated. That's why we calculated beta. How much is the beta? 0.15. Beta into what is the rm? 12.62. 0.15 into 12.62. Okay. Plus 18.93. How much is the answer? 20.82. Next, beta rm plus 18.93. How much? 22.20. Like that we calculated. Okay, now tell me, these three are called as what? Returns from the security, depending on the market. That means the market influences me 0.15 times. If the market is giving 12.62, I will be giving 12.62 into 0.15, 1.893, but I have a constant return of 18.93 even though market don't influence me. Therefore, my total return has become 20.82. 20 point what, sir? 82. Okay, now, but really it has given 20.82 or really it has given 25.62 or really it has given 25.62. Means what? Originally security has given 25.62, but CML equation if you put the return that has calculated is 20.82. Sir, I didn't understand. See here, I will go back. See here, what is the return that security has given? First year 25.62, second year 20.07, third year 17.05. These are all expected returns. Actual returns are actually happened 3 years. In the past 3 years, these are actually happened. Okay, these are actually happened. For what? For the last 3 years. Okay, these are all actual returns. I think everyone understood up to here. Okay, now complicated. Listen carefully. I will explain 2-3 times. This column is actual returns originally we obtained. How much? 25.62, 20.07, 17.05 are the actual returns we got from the security. Okay. Now, when I establish a straight line relation between market and security, straight line should fit into a equation. What is that equation? Y equal to mx plus c. If I use that equation, it is not 25.62, it is 20.82. It is not 20.87, it is 22.20. It is not 17.05, it is 19.73. Means CML, when I use a straight line equation and calculate a return, that return and the actual return what we got is the same or different. Is different. The change will be there. Originally 25.62. Straight line equation I got 20.82. There is a change or not? That error has come. How much is error? 4.80. Okay, here how much is error? 20.07 minus 22.2 minus 2.13. Okay, 17.05 minus 19.73 2.67 or 68 or 67. So if you total, error total will be 0. What I said the other time, just 10, 15, 20 minutes back, I will draw a regression line artificially in such a way that it will cut the points in the middle such that, okay, the points above that and below that will set off each other. Set off each other. This is what set off each other. Sir, okay, sir, your logic I understood, but clarity didn't come even now. Yes, it will not, because we have to complete this. Okay, let me complete everything. You can really understand the knack over this particular concept. Okay, now tell me. You should only answer the question. Okay, you should only answer. How much is the market? 12.62. What is the return? Really, I got 25.62. But when I calculate the return using CML equation by establishing relation between security and market, it is 20.82. How much change is there? 4.8%. Okay, so we got this information. Now listen carefully. Here comes the real analysis of Sharp. Okay, see here. How to analyze this is a question. Why is the differences came? It should be same, na? Listen. What is risk? Tell me first. What is risk? Risk means not getting the expected return is a risk. Not getting expected return is the risk. How many types of risks are there? Two types. Systematic risk, unsystematic risk. Okay. Systematic risk is a risk which comes from the system. Unsystematic risk is a risk which comes from the company specific factors, not because of the market. Okay, which can be controlled? Systematic cannot be controlled. Unsystematic you can control. Okay, unsystematic, can anyone explain what is unsystematic? It is company specific. In your company, bad management may be unsystematic. In my company, no technology advancements may be unsystematic. In another company, production economies of scale is not there. That may be unsystematic. Unsystematic risk is a risk which you can't explain. It's like an error which you do, no one can know. Okay, systematic risk is a risk which you can tell clearly, this is a market, this is how the risk is. Sir, I will explain this. What is a risk? Not getting expected return is a risk. Systematic risk is a risk that comes from systematic return. Unsystematic risk is a risk which comes from unsystematic return. New concept, sir. Yes. Listen carefully. Systematic risk is a risk that comes from the system. What is risk in this chapter? Not getting the expected return. Systematic risk means systematic return is there. That return, what is the chance of not getting it? Is called the chance of not getting the systematic return is called a systematic risk. The chance of not getting the unsystematic return is called as unsystematic risk. The chance of not getting the total return is called as a total risk. Till now we analyzed, till Sharp model, total risk we analyzed, that's all. We said that there is a systematic risk inside this, but how much? Bifurcation not made till now. This is the first model in the world which has bifurcated the risk into two parts, systematic and unsystematic, and shown how much is systematic and how much is unsystematic. For that only Sharp has got the prestigious Nobel Award. For understanding the concept in a deep way, very, very deep. So after analyzing all these things, when I read the book on Sharp's model, okay, literally the goosebumps. So you can at least understand how much hard work that I should have put to understand the Sharp single index. Okay, I may be from a mathematics background, I really have a good knowledge over the mathematics even till today. Okay, foundational maths I will tell. Foundational law I will tell. Okay, law subject leave off. Foundational maths, deep maths I will do. So I know the in and out regarding the stats and maths. Sir, okay, leave off that. But how much analysis and hard work that we should put to understand the model in a right sense and to deliver back the same? So listen carefully. Graph, if you draw, okay, if you draw graph for what? Graph for this information. 12.62, 20.82. That means this is CML line. This is a normal return line. We drawn graph for these two now. Plotted points are scattered, 3 points. Now we are going to draw these. Okay, these we have going to draw. Let us understand how it will look like. Okay, see here. Let's not take the chart I draw. Let's take a graph this way. Randomly, I'm drawing. Don't go for accuracy and do overaction. Okay. 5, 10, 15, 20, 25. 5, 10, 15, 20, 25. Okay. See here now. When the market is at 12.62, CML return will be at 20.82. 12.62, 20.82. Somewhere here. Don't shout at the answer. Okay, don't shout at the answer. So point above, point below. We are not going on a graph. Model, we have to understand the idea. Okay, let's not go into intricacies unnecessarily and complicate the concept. Next, market is at 21.79. Security return went to 22.2. Okay, somewhere here it will be. Somewhere here it will be. Okay, so first one, first one 12.62, 20.82. Okay, 12.62, 20.82. Okay, now third one 5.32 and 19.73. 5.32 and 19.70. 5.32, 19.73. Somewhere here. If you see randomly, we have drawn like this. If you draw correctly, it will be a straight line this way. So this equation is a straight line equation. Therefore, automatically it ought to form a straight line. It ought to form what line, sir? Straight line. Okay, now what you have to understand, the points exactly fit into a straight line. Now, points exactly fit into a straight line. Reverse line will calculate. One fun moment will come now. See here. I'm drawing from the end now. Okay, I will do one thing. Just there is a small accuracy error. Na? I will do one thing. See here. Okay. Okay, I drawn a straight line now. Exactly here, 18.93 is there. That's called as alpha. Okay, 18.93 is called as what? Alpha. How great the model is, exactly cut from alpha and it start drawing a line and it will cut the real points above and below. So how it will happen, let us try to understand. Okay, now up to here everyone understood? Okay, now I will now integrate both of them. First, see this, plot at the points. It is exactly cutting at alpha. Okay, it is exactly cutting at alpha. One point is here, another point is here. This line is 0.15 Rm plus 18.93. 0.15 is what? 0.15 is beta Rm plus alpha. Okay, beta Rm plus alpha. So security return equal to 0.15 Rm plus 18.93. So this will be giving out the value of a security return. So this is what we have done here. Okay, so now listen carefully. So everyone now understood, sir, what we have to do in exam. You have to do this step. Okay, return take from the market. Use the beta you calculated. Put it on a straight line equation. Okay, instead of using y equal to mx plus c, y is influenced. Security is influence. RS or RI, investment or security, equal to y equal to m. M means beta here, slope. Beta into, okay, Rm plus alpha. Alpha you calculated, na? So you put that. You will get a number. Returns really you got one number. Change will be there. No? That's called as unsystematic risk. Also called as a error. Meanings I will tell you. So you have drawn a graph. You have drawn what's a graph. You plotted everything on a graph. Over. Chart to explain the impact of both. This itself we have to understand with some presence of mind, please. I want every one of you stay properly, listen carefully. See here. 5, 10, 15, 20, 25, 30. 5, 10, 15, 20, 25, 30. Okay, now listen carefully. First, Take all the returns and calculate. If you want, you also simultaneously do with me. First situation, market is how much? 12.62. Okay. How much is the CML return? 20.82. Red color plotted points are CML. Black color plotted points are real returns. Okay. Okay. So 12.62 and 20.82. Somewhere here. Somewhere here. Okay. Next one. 12.62 and 20.82. Next. 21.79 and 22.20. Okay. Somewhere here. Accuracy leave off. Approximated it. Okay. Next. After that. 5.32 and 19.73. It will stay somewhere here. Okay. From this we have drawn a line. Exactly it will cut at a place which we will call alpha. This is what line? This is a CML line. When we draw a straight line equation, automatically straight line should be formed or not? It formed. So what is the name of this straight line? 0.15 RM, beta RM plus 18.93. This form a straight line. Okay. Real returns, if you plot on a graph, how they will look like? Black pen I am using. Listen. Return is 12.62. Okay. But actual return is 25.62. Here somewhere. Okay. Next. Return is 21.79, 20.07. Okay. 21.79, 20.07. Just somewhere here. Somewhere here. Next. 5.32, 17.05. Okay. 17.05. These are the plotted points. Okay. These are the actual returns 1, second year, third year. Am I clear? Okay. Now listen carefully. Okay. So let's continue further. Now, so when you see the plotted points here, see here now, I will give you one analysis. The line exactly cut the points in the middle. What do you mean by middle here? If you see the difference between this and this, the difference between this and this, if you take a scale and count, that will be the exact difference between this and this. Means the downward differences and upward differences will exactly knock with each other, resulting in the gap of 0. That's how it came. Okay, why it is 0? Because of this. How many points gap is there below the line, above the line? Both will cut at the middle exactly. Sir, how it cuts in middle? That's why it's called as a line of best fit. Line of best fit is a correct representative line where the points below the graph and above the graph will cut exactly in the middle. You take 100 information, line of best fit will calculate exactly the information. That's the beauty of the correlation model. Okay, so from this what you have to understand, some points are above the line, some points scattered below the line, but exactly a line cut in the middle. Okay, now conclusions we are going to draw. Listen, last 10 minutes conclusion we will draw, problem we will do in next 5 minutes. Listen, sir, what is this, sir? Okay, everything is okay, sir, understanding, but conclusions I couldn't draw, sir. Mechanically up to here I understood everything, sir, that, but what is this concept? Listen, what is risk? Not getting a return is a risk. How many types of risk are there? 2 types of risk. What are the risks? Systematic, unsystematic. Means a risk is not getting a return is a risk means. Systematic risk means not getting a systematic return. What is systematic return? Systematic return means a return coming from the market. Okay, now listen. Sir, in the graph, first whatever we have drawn, why it doesn't form a straight line? The question will arise or not. Why it doesn't form a straight line? But why this formed a straight line? Listen. On the x-axis, on the x-axis, what you are taking? Market. On the y-axis, what you are taking? Security. That means on the x-axis, you are taking the market, and on the y-axis, if you are taking the security, you should only consider the market influence on security. Okay. Now, you take return of 25.62. In these two returns are there. Return because of systematic factors, return because of unsystematic factors. Two things are there. Return because of systematic factors, return because of unsystematic factors. How many factors are there? Two factors are there in this. That means what you have to understand, this return, whatever you calculated using CML, will consider the market influence on the total return. What influence? Market influence. This is not the analysis of market and security. This is the market, security, and other factors. I didn't understand. And I will explain this way. In x-axis, what you have to take? Market. In y-axis, what you have to take? Security. Sir, y-axis security is done, always correct. X-axis what you are taking has become a problem. X-axis you have to take market as a base. So 12.62, 21.79, 5.32 you should take on x-axis. Yes or no? Oh, yes. Now, when you take market as a base, only market related return you should consider on the security side. That means if you take 25.62 as a return and plot on a point, 25.62 return, two returns are there. One is a systematic return, another one is unsystematic return. Unsystematic return means a return which because of my company goodwill it came, whether the market is there or not, I will get that return. That means the plotted points, sir, always a line represents what? Relation between two variables. Here, three variables are there. One is a secure, one is a market, another one is security, another one is some other factor. 25.62 is a combination of two things. What are the two things? Systematic portion, unsystematic portion put together is a total return of 25.62. Okay, that means systematic return means what is systematic? Which comes from the market. That means in the total return from the market, because of raise in the market, how much you got? 20.82. Market is at how much? 12.62. Your return is at how much? 20.82. Means what? Since market is giving a return of 12.62, my security has given 20.82. Okay, my security has given 20.82. Even if the market is 0, my security will give 18.93. That means it is independent. Whether market is there or not there, or systematic, consistent, leave off, constant return of 18.93 my security will give. Since the market is at 12.62, my beta is 0.15. So I will be having a return of 20.82. 20.82. 20.82 is called as a systematic return. This is called as unsystematic return. Market to security, if you analyze the relation, because of market, how much security is affected, means it is systematic, unsystematic, systematic because analysis of market and security is systematic. Okay, when you take systematic items on x-axis and y-axis, you should only take systematic returns. So you have considered 25.62, which is a combination of systematic return, also the unsystematic return. Therefore, those are not forming a straight line. Straight line will be formed if you correlate the relation of two variables. Here, there are three variables. What are the three variables? Market. First one is a market return. Second one is the security return because of market, and security return because of the total. Okay. So therefore, because of market, how much return you got? 20 point. Because market is at 12.62, you are getting 20.82 return. I will tell you one thing here. Market is how much here? 12.62. No, market is 0. What will happen? Tell me. Market is 0 here. Tell me what will happen. 0.15 into 0, I will get 18.93 return. Since market is listening, since market is standing at 21.79, you are getting 22.20 for the security. Okay, sir, market is at 12, I'm getting 20. Market is at 21.78, still I'm getting only 22 because your beta is very low. Beta is very low. What is a beta? Measure of systematic risk. Measure of systematic risk. Systematic risk means the risk which comes from the market, not from my company. Okay, that means when you take market on x-axis, okay, you should tell how much return on security you are getting because of the market. But in the original case, what you are doing, this 25.62 20.82 only because of the market. Then remaining 4.8 is because of what? Because of my company internal factors. Because of my company internal factors. What are the internal factors here? I don't know. It depends on company to company. That unknown we call unsystematic and error. That's how the concept of error term started in Stark's single index model. So to start drawing a straight line, you should establish a relation between market and security. But in the original 25.62, in this 25.62, what is there? Systematic return, unsystematic return, both are there. That means you are taking systematic market in the x-axis, but you are trying to analyze unsystematic also. That's why they are not fitting into a straight line. To fit into a straight line, you should establish relation between security and market and security return because of the market. So therefore, we calculated a straight line equation and we calculated it. Hope everyone understood the logic behind the sharp model clearly. Okay, so therefore, line of best fit is a line which considers only the return because of the market. Return because of the market. Characteristic market line is a return calculation under sharp model. Return calculation under what model, sir? Sharp model. Okay. So in this model, what is the new thing that we learned? In the model, we not only tell that beta, we will tell that how much is the systematic portion and how much is the unsystematic portion, which other models didn't even try. Okay. So now tell me, this is what return? Systematic return. Means what? Return that comes because of the market. So we have taken market as a base, market as a base, market as a base. So then 20 also market a base, market 0, then what is the return of security? Means market is a base again. So this is a market base, market 0, how much? If market is 12.62, how much? So market is a base. So the security return is derived from the market data. Okay, but what is this? This is a return because of the market and also because of other factors. Which factors? I don't know. Market అయితే కాదు. It is not market. Maybe company market is giving how much, sir? 12.62. How much you are getting? 20.82 because of market. Okay. So, but how you got 25.62? I worked better than the market. I worked better than the market. Am I clear, everyone in the class? Institute is giving a pass percentage. My average is 20.82. Okay, my institute, for example, I started institute X Limited. Institute has given 12% pass. My institute has given 25% pass. When institute is giving 12.62 pass percentage, how your institute has got 25.62? When institute is giving a good percentage, whether institute give a percentage or not, better percentage or not, my institute will generally give 18% on an average year. Every time when 100 people write the exam, 18 will pass, 18 or 19 will pass. If you give some better, excess of that if you give, my percentage will go to 20. But really I got 25.62. Why? You have already increased the percentage. Because of that we are passing. Our institute has done much more hard work. What hard work we have done? Exams we conducted. Okay, sessions we conducted. Because of that, again there is an increase. That means I am going over and above the market performance and I am giving the return. What is that over and above? We don't know. That's called as error. What you don't know is error. Okay. So for one last time, I am repeating, not entire thing. This is total return. Two factors, systematic and unsystematic return. Both are there. This is systematic return. This is unsystematic return. Both put together total return. Till now, we didn't analyze in any model like this. Now we are going to calculate what is the standard deviation of this. What is the standard deviation of this? What is the standard deviation of this? That itself is called as risk calculation under Sharpe's single index model. What calculation? Risk calculation under Sharpe's single index model. Okay, let's calculate. Calculation of risk. Okay. First, I will explain how the formula has been derived. Formula. Variance of a security equal to beta square sigma m square plus sigma ei square. Beta square sigma m square plus sigma ei square. Variance means not square. Standard deviation kaadu. Square. So it is simply sigma s square. Everything is square na. This is the formula. So what is this formula, sir? This is a risk formula under Sharpe single index model. Okay. So let me explain further. First, tell me what is the written formula? Beta Rm plus alpha plus EI. That's a total return. Only market return EI remove. Okay. But total return we want na beta Rm plus alpha plus EI. Okay. Tell me. Return of a security will change or will be constant? Change. Means it's a variable or constant? Variable. Beta is a slope which is constant slope. Always. Okay. Market and security will have a slope. This is a constant. RM, return from the market. 1 year 12.6, another year 21.79, variable. Alpha itself means a constant. EI. EI is a variable, obviously. Whenever RM changes, automatically EI also will change. So EI, you see the question. EI, last column, 4.82 minus 2.13 minus 2.67. It depends with the change in the security return. So it is a variable. Now, first one is a variable. Second one is a constant. Third one is variable. Fourth one is constant. Fifth one is again a variable. But independently, you should not see these two. Beta may be constant. Okay. RM may be variable. But both if you multiply is always a variable. Is always what's a variable. What is a variable? Variable is something which can vary. What is a variable? Variable is something which can vary. What can change is a variable. What will not change is a constant. That means there is no variance for a constant. There is a variance for a variable. Okay. Okay. Now tell me, what is the variance of security? Variance of a security. Okay. Now variance I want. Therefore, beta square. RM is a return. What is the risk of not getting RM? Sigma m square plus alpha is a constant. So risk will be 0 plus EI is a return. Sigma EI square is the risk calculation. This is how the formula has been derived. That's all. If you understand the logic of the formula, how much time it will take to understand the concepts here? So that's how the formula has been derived. Analysis also I will give. See here. Tell me what is the formula? Variance equal to beta square sigma m square plus sigma EI square. Why security will vary? Why security return will vary? Because market vary. I repeat. Why security return vary? Because market vary. How much security vary? Beta times the market it will vary. Okay, that means the variance will be only because of the market. No. In company, there may be other factors which will influence me. That's a total risk. Answer over. Instead of risk in this area, we call it variance here. Nothing beyond that. So don't see this as a alien story. Okay. So again, why security return vary? Because market vary. How much it will vary? Beta times it will vary. Okay. That means the security will change because market changes. Security will change because market changes. But how much time? Beta times. That's all. No, this is true. But other than this, there may be company internal factors also which will add to the risk of the security. Sir, market is performing well. Inside your company, full fraud. Then what will happen? Your EI will dominate your normal market risk. So risk will come from two factors. They're divided in this model, systematic and unsystematic. This is the only model in the entire world which has bifurcated the risks. Till now they said only systematic, unsystematic, but risk divisions are made. Okay, all this analysis I have given here. I pause the lecture and you can see this. Okay, all this, whatever I have said now, I have given the notes. So now tell me, what are the things we read? Ingredients to make this dish risk. What are the things we require? Variance of a security we require. Variance of the beta square, anyway, we can directly do 0.15 square. RM, we already had it. We already have it. So beta square, sigma m square. So sigma m we need to calculate, variance we need to calculate. Okay, that's what we are doing. See here. From the information I am doing. Base information already we had at the beginning of the problem. From there I have extracted the information. 1, 2, 3, x minus x bar. X minus x bar. What is x minus x bar? First here, see here. What I have done, I will show you. I have taken this information here. Nothing great I have done. Okay, I will do one thing. Okay, satisfied? Now see here. What I have done. Market. X bar is how much? 13.24. So 12.62 minus 13.24 minus 0.62. Okay, na? Next. 21.79 minus 13.24. 8.55. Happy? Yeah? Next. 5.32 minus 13.24 minus 7.92. Happy? Yeah? That's what. You believe me. Information taken from the problem. So, why we are calculating this? Because beta square, sigma m square. Sigma m square means what? First, we need to calculate variance of market. Okay, variance. Sorry, what is the formula for standard deviation? Standard deviation of x equal to root of sigma x minus x bar the whole square divided by n. Variance means square to this. So, sigma x square equal to sigma x minus x bar the whole square divided by n. That's why we are calculating this. So, 136.21 divided by 3 is 45.40. Okay. Security also we calculate because LHS la variance of security means sigma y square we need. So we calculated this, divided by 3 is 12.60. Error, very important. Error I have taken info directly. See here. Now I think you are convinced with the answer how we got. Okay, nothing is a direct number, everything have the proofs. Okay, see here now. Error. Year 1, year 2, year 3. Error. 4.80 minus 2.13, this. Total is 0. E minus E bar. 4.8 minus this, again same. E minus E bar the whole square, 34.71. So sigma EI square equal to sigma E minus E bar, EI minus EI bar whole square divided by N, that equal to 11.57. 11.57. Okay, now. So variance of security beta square, 0.15 square, sigma M square, 45.80 plus 11.57. So how much this portion has come? This is a systematic risk portion, 1.02. How much is this portion? 11.57. So total is how much, sir? 12.60. So 12.60 is the variance of the security. Exactly, that matches with 12.60 here. Over. This is all about Sharpe's single index model. So hope everyone understood the model clearly. This is how you need to do the problem. Okay. How you can understand this, whether to invest in this stock or not is the analysis of the Sharpe. Okay. Now, in this particular question, if you observe whether to invest in this stock or not, tell me. Should not. You should not. Do you know why? This particular company is not having more of systematic. It is having internal company risk. Change that company first. Okay. Disinvest in that company and invest in a new company. The total risk, okay, 8% is only systematic. That's called as a coefficient of determination. Till now, all the models have said that systematic is a risk which you can't identify. But in this model, they said coefficient of determination means what? How much risk you can determine from the market. They have done that. That means what is not possible to quantify previously is now quantified. 8% of the total risk of the security is because of market. Means 92% of the risk is coming from the company. For that, you can't even ask a premium because for unsystematic risk, you can't ask a premium. So therefore, please disinvest in this company first, because in the total risk of 12.6, 11.57% is because of your company factors here. That's what we call as a beta 0.15. Beta 0.15 is least correlated with the market. Means everything is your company problem. If return comes because of the performance of your company, if risk comes because of this company only. So in the total risk, 8% only you can quantify for market, remaining will come from the security. That means only that much percent you can ask a premium on that security. That means investment ideology has been changed because of the Sharpe's single index model. With this, we have completed the Sharpe's single index model with complete analysis. Same thing with the portfolio of securities also, you will do nothing great, nothing. Okay. So with this, we complete the Sharpe single index model. Okay. Hope everyone, this video has been helpful for you for understanding the entire Sharpe model. Okay. So you can put up your doubts, you can put your view on this video in the comments box in the after this particular lecture is completed. Okay. Hope this lecture is useful for everyone. So for the November 22 exams, please do listen to the entire lecture, complete it. 1.5 hours if you spend on this lecture now, you will do any problem that comes under the Sharpe single index model after this. Okay, na? Thank you very much. We'll meet again in the next session. Thank you.